Hey y'all, welcome to your very first lesson in your Intro to Statistics course. And the very first thing we're going to do is talk about organizing data. Now, one thing you're going to find in this first unit in particular is that it's very vocabulary driven. So you're probably going to need to think about your study strategies for classes more like science and history, where there's vocabulary to learn and apply. There will be some mathy things to do, but it's going to be a whole lot of vocabulary. All right, so we're going to apply the basic definitions. First of all, let's talk about data. Data simply means information in a context, and there's two basic types. Quantitative, which are numerical measurements. Basically, if it makes sense to average it, in general, you're talking quantitative data. The other type of data is called qualitative or categorical. That means you're describing qualities, or you are saying what category you're classifying the different characteristics of the objects. So in this case, it wouldn't make sense to average it. You don't average a red car and a blue car to get something else, okay? Now, statistics is simply the study of how to collect, organize, analyze, and interpret numerical information from data. Now, everybody loves woodchucks, okay? Woodchucks are just universally loved. Anyway, if you were really thinking about it and thinking about that good age-old childhood question, and you really wanted to know how much wood a woodchuck could chuck if a woodchuck could chuck wood, that would be suitable for study in collecting data and using statistics to describe that. The data we would want is the amount of wood woodchucks are chucking, and statistics would give us the methods for determining the average amount of wood chucked by a woodchuck, as well as how much that amount varies from one critter to the next. Okay, so we often talk about populations and samples. A population is simply all subjects of interest. So in our case, it's going to be all the little woodchucks in the U.S., all those little guys. The problem is it's often not feasible or simply too costly to contain all measurements or observations of interest. There's got to be some pretty crafty little woodchucks out there that would escape all our efforts of being measured. It would be really hard to get the entire population, so we would probably do a sample, and that's just simply part of the population. The sample should be representative of the population. A random sample, a sample that's determined by chance, is one that is representative. Okay, so again, let's just keep our scope to the U.S. The population that we're interested in is all woodchucks in the U.S. Our sample would probably be 100 randomly selected woodchucks from all U.S. woodchucks. When we are producing data, there's some vocabulary that's associated with that. If we conduct a census, that would be where all members of the population are used. We already talked about some of the problems with that. It would probably be hard to get some of the woodchucks because they are just quick and clever little creatures. Sampling is a subset of the population is going to be used. So we'll talk about our sampling procedures, how we're going to get a sample, how we're going to work with it. Now, there's also another way to produce data, and that's by conducting an experiment. In statistics, an experiment is a study in which a treatment is deliberately imposed on a subject in order to observe a given response. Those treatments are imposed. They're usually imposed at random. The subject doesn't get to pick the treatment. Simulation is a numerical facsimile of real-world phenomena. In other words, it's something that is done typically by software. Sometimes we use other methods to model what actually goes on in the real world rather than actually observing or conducting an experiment. So let's consider our good friends the woodchucks and our woodchucking question. And a couple of related questions. So a census would be if we studied all the woodchucks and we measured how much they chucked each day. A sample would be if we studied 100 woodchucks and we saw how much they chucked per day. An experiment, we've got to impose a treatment on them. So if we gave Red Bull or some other energy drink to 20 woodchucks and saw how much more wood they chucked that day, That would be an experiment. Simulation would be if we programmed a computer to demonstrate the effects of giving woodchucks steroids to improve their daily woodchucking output. We'd probably get some pretty interesting data. Why wouldn't we go ahead and just give steroids to the little critters and see what would happen? Well, it's not ethical. It also could be dangerous depending on just how well those steroids worked. Okay, now we're talking about measuring different things. We measure variables. And there's different levels of measurement. The first level is nominal. Nominal means name. It literally means name. So it's giving or sorting things into categories, measures or names only. Okay, there's not one that's better than the other. It's simply a way of categorizing different individuals. Now with ordinal, see how it kind of sounds like order? That means that the categories and measures, the name, actually convey some sort of rank or order for the observations. This is like coming in first, second, or third. Okay, it's better to come in first than third. It's not better to be a blue car or a red car. So blue car, red car, that's nominal level. Coming in first, second, or third is ordinal level. Okay. Interval level. Of course, it's going to give names to everything, and there will be ranks and orders involved, but there's meaningful differences between data values, but there's no absolute zero. A good couple of examples of that are measuring temperature in degrees Fahrenheit or degrees Celsius. 0 for both of those do not mean an absolute lack of heat. So that would be an interval measure. Okay. In this case, it makes sense to say, let's say it was 80. Oh, this is Houston. It could have been 40 degrees Fahrenheit yesterday and 80 degrees Fahrenheit today. We could say that there's 40 degrees difference because 80 minus 40 is 40. So there's a 40-degree difference, but you couldn't really say there's twice as much heat in the air today, even though 80 is 2 times 40. So you can talk about the interval between the two measures. Okay, and 80 is certainly warmer than 40, but you can't make a ratio out of them. You can't do 80 divided by 40 is 2, so it's twice as hot. You can't do that for Celsius and Fahrenheit. That's why there's that fancy Kelvin scale, which is used in science a lot, because 0 degrees Kelvin means absolute lack of heat. So again, it has all the characteristics of the previous levels. You're going to give it a name. There's going to be order. There's meaningful differences between values, but there's also meaningful ratios between values. And what makes that happen is that there's absolute 0. So if we were measuring in Kelvin and something was 50 degrees Kelvin and 100 degrees Kelvin, you could say that the 100 degrees Kelvin had twice as much heat as the 50 degrees Kelvin. All right, back to woodchucks because we love them. Nominal level, that would be the classification of woodland creatures as woodchucks, squirrels, beavers, chipmunks, marmots, and others. So you are a woodchuck or you're not. Okay, the different things. It's not necessarily better to be a chipmunk than a woodchuck, but there is a difference between being a chipmunk and a woodchuck. Ordinal level, that would be if we had a woodchuck contest and declaring some to be excellent, good, adequate, poor, and pathetic. It's better to be excellent than pathetic, so there is a ranking in the ordinal level. Interval level, again, degrees Fahrenheit is awesome for interval level, so that would be the body temperature of a woodchuck in degrees Fahrenheit. For ratio, we're not going to talk degrees Kelvin because we typically don't do that when we're talking about the body heat of animals. Height is a good example. The height of woodchucks in inches. So if we had one tiny woodchuck that was, 2 inches tall, and then one that's 4 inches tall, and then one that's 8 inches tall, the one that is 4 inches tall would be twice as large as the one who is 2 inches tall, and the one who's 8 inches tall would be twice as large as the one who's 4 inches tall. And the one who's 8 inches tall would be 4 times as tall as the one that's 2 inches tall. And the theoretical woodchuck that had no height would have a height of 0 inches. There is an absolute 0 for that. All right, guys, that's it for lesson 1.1. You are ready to do the problems to try on your own and then tackle the classwork. Thank you for listening. Come see me if you have any questions. Have a good day.